Okay, welcome to 5.4, Factor and Solve. So this one is all about factoring. So grab your factoring flowchart that you should have gotten a couple days ago. Here is the factoring flowchart that I want you to use. You're always looking for a GCF. So if it does have the greatest common factor, then factor the GCF. Okay, and then move on. So we're going to add to this as our lesson goes. So you're looking for either 2 terms, 3 terms, or 4 terms, and we'll refer back to this. If there's no greatest common factor, then you just proceed with the 2 terms, 3 terms, or 4 terms. So let's go on. All right, and so what we're going to do is here's our key concept box. Factoring completely. We touched on this in the last chapter, but if factoring completely is a product of unfactorable polynomials with integer coefficients. So for example, if I had to do, if this was going to be 2x plus 6 times x minus 3, that wouldn't be factored completely because this can still be factored. Right? This one is unfactorable. 2x plus 6 is still factored. So if I factor out a 2, now I'm going to write x plus 3, because 2 times x and 2 times 3, and then times x minus 3. Now I've got polynomials with unfactorable that can't be factored anymore with integer coefficients. Okay. This one, examples right here, the 3x times x squared minus 4, that is still not factored completely because you have a difference of squares there. So I'll do a different example. So for example, if we had 2x times x squared minus 9, so you have a different example to follow. 2x is okay, but this is, see if we write 1x and 1x and 1 and 9, 3 and 3, we are looking for something that adds up to 0. So those would be it. And so we will still write our 2x, and then x squared minus 9 can be written as x minus 3 and x plus 3. And that is a pattern you want to notice right away. That's called the difference of squares. So go back to your factoring chart. So if you get 2 terms, one of those is going to be a difference of squares. So that's one of the 2 terms. We'll have 2 more to fill in later, but difference of squares. So if you have, we could just use our example. So x squared minus 9, or let's do 4x squared because that's a little bit more complicated and you will see that eventually. That is still a difference of squares. So 2x is being squared and 3 is being squared for the 9. So it would be plus 3 and minus 3, and that would give your 0, your middle term adds up to 0. So that is one possibility if you have 2 terms after you factor out the GCF. Okay. So let's factor for A, which you don't have that. For A, it would be x cubed plus 2x squared minus 15x. So you're always looking for a GCF. No numbers are the GCF, but there is an x to each of terms. So we're going to factor out the x, and then inside I will get x squared. So x times x squared is x cubed, and then plus 2x minus 15. All right, so now we have 3 terms. So if you go back to your factoring chart, one possibility for 3 terms would be ax squared plus bx plus c, and we have a couple more to fill in there that are new to Algebra 2, but that is left over from Algebra 1. And so you would either use Clinton's magic or write down your terms. So for this we would have 1x and 1x, and then things to multiply to 15 are 1 and 15, and 3 and 5. And since this is a minus sign, we're looking for a difference of positive 2. So that would have to be a negative 3 and a positive 5. Right, so I'm going to rewrite that as x minus 3 and x plus 5. And then don't forget about that GCF. Right, and everything is written as a product of unfactorable polynomials, so that is our final answer for A. For B, we have 2y to the 5th minus 18y cubed. So it is two terms, so I'd be looking for a difference of squares, but the very first thing we have to do is see if there's a GCF, something common to both of them. They're both even, so 2 is common. And then the smallest variable is y cubed, so that would be 2y cubed would be the greatest common factor. And then what we have left inside, well, 2y cubed times y squared would give you what we had up here. And then 2y cubed times negative 9 would give you what we had up there to begin with. So we factored out the GCF, but we do have a difference of squares here. So something that adds up to 0 for the middle term, and that would be y minus 3 and y plus 3. So if you can recognize that pattern, you'll have an easier time of factoring those. And then our last example is 4z to the 4th minus 16z cubed plus 16z squared. Okay, so we're always looking for a GCF. And let's see, they all have 4 in common. And the greatest common factor for z's would be z squared. They all have a z squared in there. So then we ask ourselves, what times 4z squared is equal to 4z to the 4th? That would be z squared, and then minus 4z minus positive 4, plus 4. Right? And then you can either use Clinton's magic or writing down your factors. Either one is fine. You could also use guess and check. So we're looking for something that multiplies to positive 4 but adds up to negative. So these both need to be negative. And so this would be negative 2, negative 2z, and negative 2z. So we'll rewrite that as z minus 2 times z minus 2. Don't forget about your GCF, so 4z squared. You can also write that as 4z squared times z minus 2 quantity squared. Either answer would be fine. Okay, just don't forget about your GCF. Right. Okay, our next key concept is the sum and difference of two cubes. This is a new formula. Every time you use it, please write it down, so by the time the test comes, you will not need to memorize it. All right, so I'll just do an example of the sum of two cubes. All right, the sum of two cubes. All right, so that is a cubed plus b cubed. So after you take out a GCF, you're looking for two terms. And these are going to factor into a plus b. So a, whatever's being cubed, and then b. And then, so it's the same sign. So a plus b, it's the same sign here. So same sign, and then it's the formula is a squared, opposite sign, so it'd be a minus ab plus b squared. So please write the formula every time you use it. And then for our example, we have 8x cubed plus 27. So basically we need to figure out what's being cubed for 8x cubed, and we need to figure out what's being cubed for 27. If you don't know that right away, that's okay. By the time you get done with guided practice, you should have a pretty good idea of some basic cubes. So 2x is being cubed for 8x cubed because 2x times 2x times 2x. 2 times 2 times 2 is 8, and x times x times x is x cubed. So this is our A. And then 27, 3 times 3 times 3 is 27. So 3 is our B. And now all we have to do is write it as our formula. So our A is 2x, so we have 2x, B is 3, so 2x plus 3, and then write the rest of the formula. So 2x squared, make sure you're squaring everything. So that would be 2x times 2x, which would be 4x squared. A lot of people accidentally put 2x squared. So this should be 4x squared, and then different sign, so opposite sign minus, and then you multiply A and B together. So 2x times 3 is 6x plus, and then you square B, so B is 3, 3 squared is 9, and we are done with that problem. Okay. So let's go back to our factoring chart and write that down. So two terms, you're either looking for a difference of squares. Now you're also looking for a sum of cubes. So a sum of cubes. And so our formula is a cubed plus sum, meaning plus. A cubed plus b cubed factors into a plus b, so same sign, and then a squared, opposite sign, minus ab plus b squared. And while you have your sheet out, we'll do an example, but let's add in also the difference of cubes. So for two terms, you're going to look for any of these possibilities. So difference is a cubed minus b cubed, and that follows a similar pattern. It's the same sign, so that factors in a minus b times a squared, opposite sign, so plus ab plus b squared. And again, if you write down the formula every time you use it, you should have no problem with the sum and difference of the cubes on the test. Okay, let's do an example for difference of cubes. So I'm going to rewrite that again. Difference of cubes. So that is the a cubed minus b cubed. And that is going to factor into a minus b, so same sign in the middle. And then a squared, opposite sign, so plus ab plus b squared. Okay, so for an example, we have 64x cubed minus 1. So we basically need to figure out what is being cubed for A and what is being cubed for B. The minus sign is not going to factor into it. That's part of the formula. So you're just looking at the number, the positive part of the number. So for 64x cubed, it would be 4x. And again, if you didn't know 4 cubed was 64, by the time you do guided practice, you will. And then for 1, it would just be positive 1. So the minus sign is part of the formula. It's just the positive part. So 1 times 1 times 1 is 1. And so you have your A and your B, and now you're just going to plug them into the formula. So it would be A minus B, so 4x minus 1. And then A squared, make sure you square everything. So that would be 4x times 4x. So 4 times 4 is 16, and x times x is x squared. And then for AB, 4x times 1 is just positive 4x, same sign. And then 1 squared is 1 times 1, which is plus 1. And we are done there. So that's an example of sum and difference of cubes. Okay, so we'll do some more examples. So for A, all right, that looks like that is a sum because of the plus sign in the middle. So we are going to first write the formula. So a cubed plus b cubed, that is going to factor into same sign, a plus b, and then a squared, opposite sign would be minus ab, multiply them together, and then plus b squared. All right, so now we just need to figure out what a and b are. So we've got that, we've got that. So x would be our a, because x times x times x is x cubed. And then for our b, we know that from the last example, that would be 4. So this is our b. So we are just going to plug a and b into our formula. So this is going to factor into x plus 4. and then same sign, and then squaring a, so that would be x squared. Multiply those together and with the opposite sign, so minus 4x, and then 4 squared would be 16. And that is our final answer. And then for B, that would be a difference. So we have part B, it's 16z to the 5th minus 250z squared. Again, you're always looking for a GCF. So the greatest common factor, we definitely have a z squared in there and also 2. So when I factor out 2z squared, inside we get 8z cubed minus 125. So that is a difference of squares. So we have a cubed minus b cubed, and write the formula every time you use it. So same sign there. Then we have a squared, opposite sign, and multiply them together, ab plus b squared. All right, so now we just got to figure out, we'll add in 2z squared later, but we're going to figure out what's being cubed for 8z. And the minus sign, remember, is just part of the formula, so it's not going to be a negative number. Figure out what's being cubed. So our a would be 2z, and b would be 5. So it's not a negative 5, it's just positive 5. So when we use our formula, it's 2z minus 5, the same sign. And then inside here, 2z squared. Again, make sure you're doing 2z times 2z, so that would be 4z squared. Multiply those two together, so 2z times 5, and opposite sign, so plus 10z. And then square 5 and you get 25. All right, so our final answer, don't forget about the greatest common factor. So it would be 2z squared, and then times 2z minus 5 times 4z squared plus 10z plus 25. And that is our final factored answer. Okay. So for the guided practice, make sure you look for greatest common factors. 3 of them have greatest common factors, so please look for those first and then factor. So 2 terms, 2 terms, 2 terms, and 2 terms. Go back and look at your chart. When we look back at our chart, that could be the difference of squares, sum of cubes, or difference of cubes. All right, and then we are going to factor this polynomial, which is 4 terms. So go back to your chart, 4 terms. So always check if you can factor out a GCF, do that first. If not, then you look for how many terms. So 4 terms we're going to factor by grouping, which you may or may not remember from Algebra 1. So for this example, we've got x cubed minus 3x squared minus 16x plus 48. So we are going to group them. We're going to group the first 2 and the last 2, and we're going to look for GCFs. So the GCF of the first 2 would be x squared, and then inside x squared times x is x cubed. X squared times negative 3 would be negative 3x squared. And then for our second set, we're looking for the GCF of negative 16x and 48, which could be a positive 16 or a negative 16. We're trying to get the parentheses to match, so we want to x minus 3 again. So if I factor out a negative 16 times positive x, and then a negative 16 times negative 3 will be positive 48, and now I have things that match. Okay. So what I'm going to do is, since I have x minus 3 both places, I'm going to factor that out. So we have x minus 3 now as the GCF, and then I'm going to put these 2 together in the same parenthesis. So x squared minus 16. Okay, if that didn't make any sense, let me explain. So if I have x squared times star, and then I have negative 16 times star. Since I have the same star, both sets, what I'm going to do is factor out the star. Okay. And then inside I would get x squared minus 16. Okay. Now when I multiply it back out, I would get x squared times star and x squared times, or star times 16. So instead of star, it's now x minus 3. And I can explain that more in class as well. All right, so now I check if it can be factored anymore. X minus 3 can't, but x squared minus 16 is two terms and it can be factored, and that would be a difference of squares. So I'm going to write that as x minus 4 times x plus 4, because the middle term adds up to 0. And then I have factored that completely. Okay. We also have another one. It's quadratic form. And you'll see that, let's do 16x to the 4th minus 81, right? This is similar to 16x squared minus 81. So if we do the algebra 1 example first, you might see this is a difference of squares. So what's being squared here is 4x, and what's being squared for the 81 is 9, and our middle term adds up to 0. Okay, so that's the algebra 1 part. When we go to the algebra 2, 16x to the 4th, it's still something that's still being squared. It would be 4x squared minus 9 and 4x squared. So 4x squared times 4x squared is the 16x to the 4th. And then 81 is 9 is being squared for 81. And so we still have a middle term that adds up to 0. Okay. This part cannot be factored anymore, but the first part can, because now we have a difference of squares. So this is going to factor as 2x minus 3 and 2x plus 3. And then don't forget about this one, 4x squared plus 9. Okay, and we will practice that some more. But it follows the algebra 1 pattern. All right, for part B, and then just for part B, we have 2p to the 8th plus 10p to the 5th plus 12p squared. Right, you always look for a GCF, and this has a GCF of 2p squared, so I'm going to factor that out first. And then I would get p to the 6th plus 5p cubed plus 6. So notice that 6 is still just a number. And so this is going to factor exactly like the algebra 1 version would be of p squared plus 5p plus 6. So it's the same thing. So I'll do it writing the factors and with Clinton's magic. So when we write the factors, this is going to be the same exponent. So you don't need to worry about p squared or p to the 4th. They're going to be the same. And then write the factors of 1 and 6 and 2 and 3. And we're looking for something that adds up to positive 5. So this would be 2p cubed. This would be 3p cubed. And when you add those up, you get your middle term. So using guess and check, we bring down our GCF, and then we had p cubed plus 2 and p cubed plus 3. We can't factor anymore, so we are done there. Okay. Using Clinton's magic, let's see, we have p squared, let's see, let me rewrite this. P to the 6th plus 5p cubed plus 6. So using Clinton's magic, we would put 6 up here and 5p cubed up here. And then here would be p to the 6th and p to the 6th. Okay. So the factors that work are 2p cubed and 3p cubed. So we would write them underneath 2p cubed and 3p cubed. Since those multiply, 2 times 3 multiply to 6, and then they add up to 5. Okay, and then you would reduce like normal, rather than reducing, sometimes you'll reduce numbers. Here you're going to reduce just the variables. So that would be p cubed on top over 2, which is right here. And then this reduces to p cubed on top over 3, and that factor is right there. Okay, so, and then I'll finish that out. So p cubed plus 2 times p cubed plus 3, and then please don't forget about your GCF of 2p squared. Right, so when we go back to our factoring flowchart, so for 3 terms, now you're also looking for quadratic forms. So that would be ax to the 6 plus bx cubed plus just a number. It also could look like ax to the 4th plus bx squared plus c. You're still just factoring it just like you would in Algebra 1. All right, so let's see, number 5, again, it's 4 terms, so refer back to your sheet. 6, that one you're factoring it just like you would for 16g squared minus 625. And then number 7, look for a GCF. All right, so we're going to actually solve now. So we're going to find real number solutions, which means we need to get everything to one side for it to equal 0. So if I write it in standard form, we're going to subtract 18x cubed. So we're going to put that in the middle, and that equals 0. So now I'm still looking for GCFs. So the greatest common factor would be 3x. So I would be writing x to the 4th minus 6x squared plus 5 equals 0. All right, this is a 3-term, and it's the quadratic form. So please remember, it's just going to factor like x squared minus 6x plus 5. So when we write down our factors, we're looking for, again, these stay this x squared. These have to be the same exponent. And then 1 and 5, and that's it. And since it's positive 5 and there's a negative in the middle, these both have to be negative, and that's the way it works. Right, so we have 3x times x squared minus 1 and x squared minus 5. Since we're solving, we don't have to factor completely because we can take these and do the square root method with this. So when we solve, we have 3x equals 0, we have x squared minus 1 equals 0, and x squared minus 5 equals 0. These are all the x-intercepts if I was graphing. So divide by 3, x is going to be equal to 0. For this one, I add 1 to both sides. I get x squared equals 1. When I square root both sides, I get x equals plus or minus 1. When I add 5 to both sides, I'm going to get x squared equals 5. Square root both sides, and I get x equals plus or minus 5. All right, we could also write this as 1 and negative 1 and 5 and negative 5. All right, so those are all my solutions. So when I graph this, or when I look for the answers, D is my only option. If I were to graph it, my leading coefficient would be 3, the degree, so that would be a positive leading coefficient. This is an odd number, so when I graph this, I'm going to start low and my end behavior will end high, right? And we'll get into graphing later for these, don't worry. Right, guided practice again, so this one is already solved for 0, so look for that GCF and factor. This one, make sure you move everything over and then factor and solve. Now your favorite part, the word problem. So please pause it, see if you can figure out what's going on, and then unpause and we'll break this down. All right, so we're trying to figure out the volume, right? We know the basin sides and bottom should be about 1 foot thick. That's going to help us. The outer length should be twice its outer width and outer height. So that's already labeled for us. So this is, the length is twice its outer width and height. And then the sides and the bottom are 1 foot. So we need to figure out what the outer dimensions of the basin would be to hold 36 cubic feet of water. So to hold 36 cubic feet of water, we need to find the inside dimensions first. So volume is length times width times height. So the first thing we're going to do is find the inner length because the outer part cannot hold the 36 cubic feet of water. It's just the volume of the inside of the basin. So our volume is 36. Our length, let's see, if our length is 2x, but the sides and bottom should be 1 foot. What's going to cut into our length is 1 foot over here and 1 foot over there. So our length for our inside is going to be minus 1 foot on the left and 1 foot on the right. So our length would be 2x minus 2. Our width is kind of the same idea. So here's our width. Our width is x, but that's going to cut in. Our width right here is going to be, let's see if I can, so here's our width of x, and it's going to cut in right here and right here. So since the sides are going to be 1 foot thick. So here's 1 foot, here's 1 foot. So our width for the inside, the water that's going to hold, would be x minus 1 and minus 1 for the left and the right. So that would be x minus 2. And then our heights, since the bottom, all right, let's see. So here's our height of x, and the bottom is also going to be 1 foot thick. So for the inside, our dimensions are going to be x, take away that 1 foot for the bottom thickness. So that would be x minus 1. All right, so now we got a fun problem to solve. So we're going to multiply. We can't, it's not set equal to 0, so we can't solve yet. So we're going to multiply these two together. Whatever I get, I'll multiply this product with this. So if you like to distribute, distribute. If you want to multiply in a box, go for it. So please pause the video and multiply it out and make sure your answer matches up with mine. So when I multiply the first two, I would get 2x squared minus 2x minus 4x plus 4. So this one would be 2x squared minus 6x plus 4. Right, and then I'm going to multiply that with x minus 1. All right, so I need a little bit longer box for that when I multiply. And you can distribute if you'd like, but we're going to get x minus 1 and then 2x squared minus 6x plus 4. So when I multiply those, I would get 2x cubed minus 6x squared plus 4x. And at the bottom, I would get negative 2x squared, a positive 6x, and a negative 4. So my volume of 36 is equal to 2x cubed minus 8x squared plus 10x minus 4 when you combine like terms. All right, so now we get to subtract 36 from both sides. Okay. So we've got 0 equals 2x cubed minus 8x squared plus 10x minus 40. Okay, so this is a 4 term, so we would factor by grouping. So we're going to factor this by grouping, and so that would be 2x squared, and then x minus 4. And then we would factor these two by grouping, and so that would be 10 and x minus 4. And then we have 0 equals 2x squared plus 10. We'll put those two together and x minus 4. Right, so when I set this equal to 0, right, and set this one equal to 0, we're going to subtract 10 from both sides, and we get 2x squared equals negative 10. When I divide by 2, I'm still going to get a negative number, and we can't have a negative length, so we automatically cross this one out. If I add 4 to both sides, I'm going to get x equals 4. So that would be what x is, and then I'm still looking for the outside length, so go back to your picture. Our length was 2 times x, so that would be 8 feet. 2 times 4. Our width and our height would be the same, of 4 feet and 4 feet. Okay. One thing on the guided practice that I noticed for this one, 128 is not correct. It's actually 40. It's actually 40, right? So please don't use 128, use 40 cubic feet, and you should find your answer. Okay, thank you for listening to 36 minutes of me drone on.